Hey everybody, David Rainey, the AI Guide, back with you on Wednesday instead of Tuesday because of coronavirus delays. Everything went crazy this week. I hope you're safe, your families are safe, and that you guys are hanging out at home and staying away from catching it. So last time we talked about the second boom and bust period of AI, and we had just finished that period, which was around the mid 1980s when things went bust. And then we get to the 1990s, the mid 1990s, and things are starting to take off again. The 20 years from 95 to 2015 really were a watershed time for AI because this boom has lasted with no bust. So what changed? What caused things to keep growing in AI, to keep attracting funding, and to keep applying it to so many new things? So there's two things really that changed during this 20-year period from 95 to 15. The first is huge advances in computing power. At first, it was the creation of large data centers at the beginning of the period into the middle of the period. And then towards the end, the advent of cloud computing with basically unlimited computer resources on demand from a cloud environment. So you don't have to have this huge infrastructure. You can just rent it. And that's made a huge, huge difference to AI research. The other thing that made a huge difference was a breakthrough right at the end of the period in neural networks. And that breakthrough was caused by finally being able to get the different layers of the neural net to be able to talk to each other. And that was a critical breakthrough because until they could get the layers to work together properly, neural nets really weren't going to be able to do that much. So with all of this computing power and with neural nets, what do we see now? Well, on the machine learning side, which neural nets are a subset of that, but I'm talking more about traditional machine learning, algorithms were able to be created to do very specific tasks. And with the additional computing power and huge new data sets, those algorithms began to really work properly. Where is all this data coming from all of a sudden? Well, it's coming from a lot of places. First, to take healthcare for an example, there was electronic health care records that were implemented from the mid-90s to 2015 or so. They're pretty ubiquitous now. They don't really, different systems don't really talk to each other that well, but you can still get the data out and apply an algorithm to it. So that's one source of data is electronic health records and all kinds of records, right? The internet has resulted in a huge amount of data. Amazon is a data business. It's not as much a physical business as a data business. Why? Because everything they sell now is based often on recommendations, and those recommendations are a result of what you've done already on Amazon. So all of this data coming together, and then that data was added to by all the trackers that people have started to wear. The Apple Watches, the Fitbits. I have an Aura ring from Finland. It's very cool. But all of this data, and this is more towards exercise, physical health, diet, things like that, can create some very, very good use cases for AI. So clearly with all of this data, particularly in medical, but also in retail and other areas, there's a lot more background data to tell the AI what to look for or to help it find commonalities in all that data. So the traditional machine learning linear program, like an expert system, type of thing is really for a very specific use. And an example of that might be to teach the AI how to find a specific kind of cancer, and you're going to give it a lot of information about a lot of patients that have had that kind of cancer, what their symptoms were, how quickly it developed, how curable it is, all this stuff. And then that AI can evaluate new cases and say, yes, this person has this cancer, or no, this person does not have this cancer. Another example of that, again in healthcare, is in reading tests that people are given. We'll talk a lot more about all this stuff later. On the neural net side, neural nets are really good at inference, right? So what you can do with a neural net is load a ton of data into it and ask the AI to look for commonalities in that data. Sometimes it's things that humans would find. Sometimes it's wholly unexpected things. And that's really cool. One example of an AI that has been very helpful lately is in space. I have a NASA t-shirt on that I wear to do my program. I love space. And an AI was created over in the Netherlands to look for asteroids. And this AI was recently created, and it's found at least 4 asteroids that had never been discovered before. And these are potentially hazardous asteroids. So AI can find things that people can't, or AI can augment what people can already do. So that's pretty much it for today. I don't want to go past that because this period from 95 to 2015 was really a foundational period for AI to become successful. Next time, we'll wrap up history by talking about the period from 2015 to 2020, which is very short, but AI has gone exponential. So I'll see you on Saturday for that. And thank you so much for watching my channel. Please leave comments if you like what we're doing, if you don't like it, and also subscribe. Take care and talk to you on Saturday.